At the outset, let me thank Dr. Sid Thurston for this opportunity to come here, kindly inviting me. This is my first time in EarthX, and I am really happy to be here. It's a great honor and also is a pleasure. Thank you for inviting. It's a great opportunity. And I'm going to talk about the modeling aspect of global oceans. By training, I'm a physical oceanographer, and then started doing ocean modeling, and then moved to climate modeling. So mostly, I have been doing climate modeling, predictions, and applications. But this, with this decade program, UN Ocean Decade program, I got involved into the ocean modeling activities again, and the prediction activities, and also the DITTO activities I will present to you a few minutes later. And the idea of all this is to kind of understanding our link with the oceans, as the theme of this session is healthy ocean for healthy return of our investment. So first thing is healthy ocean, and then you can expect a return from that healthy ocean. And we know that we are already dependent on several things. This morning team already set all these things, like 20%, 25% of global carbon is kind of regulated by global oceans. Oceans also regulate temperature. If oceans are not there, the atmosphere will be heated by 42 degrees already. We are talking about 1.5 degrees, 2 degrees. But if oceans are not there, and they are not regulating the temperature, the atmosphere will be heated already by 42 degrees. The amount of greenhouse gases we have emitted and the radiative flux we are getting, excess radiative flux we are getting, the atmosphere would have been already heated by 42 degrees. 3 billion people, close to 3 billion, maybe more than 3 billion people are dependent on oceans for various kind of economy and various kind of livelihood. And like 90% of global trade happening through this shipping. So in that sense, we are also dependent on ocean. We are also dependent for food, renewable energy, also medicine. Team touched on that this morning. And then biodiversity and recreations. So for all that, we depend on oceans, but oceans are challenged by our activities. And overexploitation, habitat destruction, climate change, pollution. Pollution is a big factor now. The plastic waste, the oil spills, chemical runoffs. And together with the global warming, we have also harmful algae and bacteria like cyanobacteria, rotavirus, all that are affecting our health and also the ecosystem health. So in both ways, this kind of activities, human activities, are influencing our oceans. And to get a healthy ocean, to get a healthy return from the oceans, we need to improve on that. On top of that, we have the extreme events, like marine heat waves. Earlier panel discussed about that. And then we have this kind of coastal hazards because of extreme events. Indonesia, you talked about that. We have also that even in US. There are hurricanes and other things which are bringing storm surges and also destructing the coastal resilience. So in order to improve all those factors, all those things, we need to have an understanding of our oceans. And for understanding, we need observations. For predicting, we need the models. But that's not enough. Those two are not enough. We have the models, we have the observations, but how do we connect them and then get the information which is useful for our stakeholders? I think we heard it in the earlier panel discussions. We have monitoring systems, we have the observations, we have the models, which are giving good forecasts, but then are those useful to the stakeholders? Do the stakeholder understand what we are providing? There's a big gap in that. So in order to kind of fill that gap, we need smart interfaces, which can be used not only by researchers like us to run our models to see the results, but also common stakeholders like fishermen, the policymakers. They can run through the what-if scenarios. If the climate heats up like 2 degrees centigrade, and we heard Ray talking about the stratifications. So the ocean will get heavily stratified, nutrients are not reaching the top, then what happens? What happens to our biodiversity? What happens to our fish stock? Those kind of what-if scenarios can be run by anybody, not necessarily only researcher who knows about the physical parameters, biological parameters. But those who don't know anything about that, but they just have some questions, and put those questions like in ChatGPT and get the answers, both in terms of textual information and as well as graphical informations. So to do that, we need the smart interface. And if you combine all those things, for many people, digital twin means many things. Digital twin is a kind of narrative coming out of ocean decade activities. We have 10 challenges, and challenge 8 is about to provide kind of digital information about the ocean for multiple stakeholders. And in that, we have researchers and also the common people who want to use them. And many people think many ways, like a digital twin means model, it is just a monitoring system or interface, but actually it is a combination of everything. And there is not a single digital twin. We call digital twins. There is no digital twin, because each problem has its own solution. So we have many digital twins. And then a network of digital twins will provide a large language model to create a kind of AI, ChatGPT kind of thing, which can be used by multiple stakeholders. That's the idea. The framework is something like this. We integrate all kind of data. Then we have advanced processing systems, like the models, the AI techniques, enhanced analysis. And then the third thing is to have a good data interoperability. Like Cooper was saying, you have the citizen science ocean data coming out from the fishing boats. And those data must be quality controlled and also should be interoperable with the other data so that we can integrate the observation coming from different sectors, citizen science, NOAA monitoring observations, JAMSTEC observations, and then put them together so that it can be used by the models for the assimilating the data and also for common people to see what is happening at this time. Then develop a good computing infrastructure, because those things need a lot of computing power. So we need a good computing infrastructure, cloud data servers. Then the smart user interface, I already talked about that. And then the last one, last but not the least, is education and capacity building. We also heard about it in the previous panel discussion. We have a good model, we have a good interface, but the people who are using them, they don't know about it. So there we need the capacity development. There we need the education, both ways. We need to learn from the stakeholders what they need, and the stakeholder must know what we are providing. Like many of the stakeholders need information in a deterministic way. We have been working with Tokyo Electricity Company, and the idea was to provide them temperature predictions for next 2 months, so that they can have their logistics to address those temperatures, either below normal or above normal temperatures. And they just needed absolute temperatures, which was the most challenging thing for us, weather and climate predictors, to provide absolute temperature. What will be the July monthly temperature predicting now? It was a real challenge. We tried to give them probabilistic forecast many times, tried to teach them how to use the probabilistic forecast, but at the end we failed. So we need a society which can be able to use the products we are preparing, and for that we need the capacity development on the society level. And then the DITTO framework. So I'm one of the co-chairs. We have now 4 co-chairs. Fei Chai from China, Joanna Staneva from Germany, and Marina Tonani from France, Mercator Ocean, and myself. And then we have a team of 17 group members divided into 5 groups: sustainable ocean observations, integrative DT models, digital twin models, then addressing interoperability and also future-proofing the digital twin architecture. And the 4th and 5th are equally important: community interface and engagements and capacity building again. So these are the 5 teams working on those 5 themes. And besides the working groups, we have the use cases. So there are several use cases. If you go to the DITTO website, you will see there are already several use cases listed there. And in the last 3 days, I have also seen several use cases here. Not only academic use cases, but also commercial use cases. We had several talks in last 3 days. In Japan, I think Fujitsu is working on a digital twin of subsurface ocean to kind of twin the ecosystem, which can capture carbon. The idea is to understand how much carbon can be captured by the existing ecosystem. And then I think there are several studies in China, different bays like Xiamen Bay. They have a digital twin. There are several. I think Hong Kong has a digital twin. In Jamstack, we are developing digital twin. I'll present to you about that in a minute. And then not only these digital twins are used for academic and commercial purposes, but also for like movie industry and gaming industry. Because movie industries and gaming industry, they want to be more realistic with real kind of physics and dynamics involved in their movies when they are dealing with oceans. So in that sense, I think the digital twin technology, digital twin ocean technology, can be utilized by various other fields, not necessarily only for use in research and applications like fishery or other warning systems. As a case study, I will present to you about the JCOP model, Japan Coastal Ocean Predictability Experiment. This is one of the digital twin we have been developing at Jamstack. Starting in 2000, I think we will already have 25 years developing this one. This is kind of taking all kind of observations available and then making the predictions and then providing them to various stakeholders. We have different models, 10-kilometer global models to 200-meter coastal models. I know there are several centers which are now developing 10-meter coastal ocean models. The idea is good to have high-resolution models, providing predictions at 10 meters to 100 meters, because that is what the stakeholders need at that resolutions. The problem is, when you are predicting at that scale, we need to validate our predictions, and we don't have observations. Cooper was telling that before. In the coastal oceans, we don't have so much of observations. And on that resolution, it will be very, very challenging to have a sustainable monitoring system to both provide the data for data assimilation and also for validation. That's a challenge we need to discuss, and I think the citizen science is one way, but there could be other ways to make a sustainable observation around the coasts. Nevertheless, we are trying to improve the prediction so that it can be used by the stakeholders at those resolutions. The Jacob data is used by shipping, fishery, renewable energy, even like sports. The Tokyo Olympics, they were using some of the products for the yacht race and kind of things like that. And then the 10 kilometer data is available for anybody to download. And we are preparing a smart interface so that people can even analyze the data. Instead of downloading, you can analyze and take the products, the analyzed products. And on top of that, we are kind of developing this kind of 4-dimensional. At the moment, it's not 4-dimensional, it's just 2-dimensional, but interactive smart interface so that you can pick up the parameters, you can pick up the products, and you can also pick up the regions in a 4-dimensional way so that you can see the movies or also kind of get the information or data necessary for the required purposes. We are trying to extend these predictions. These predictions, as you know, are driven by weather models. The Jacob is run by NCEP's GFS, which is kind of providing 2 weeks, 16 days ahead predictions. But to extend that to like several seasons ahead, we need climate predictions. And we have the climate prediction model, SyntexF, developed together with European centers. And this model is able to predict El Nino Southern Oscillation, Indian Ocean Dipole, monsoon realistically. So we have some kind of confidence on this model. And what we are doing now is extending those coastal predictions to several seasons ahead using climate predictions. And there are some studies now which are linking El Nino with coastal circulations, dipole with coastal circulations. And in that way, we have some kind of predictability in the system, and we want to tap into that and get the prediction extended to several seasons from several weeks. And there are other use cases like there is one use case I remember from Woods Hole Oceanographic Institute. I think Dr. Ann Cohen. She has developed a digital twin for the Palmyra coral reef. And the name is, I think, coral or digital reef. And if you Google, I think you will get that. And many other centers are kind of inspired by Ann's coral model. And this one is the model developed at the Hong Kong University. This is a kind of digital one. It's not real coral reef, digital coral reef, but based on realistic data. So the idea is to create coral reefs so that you can do your what-if scenarios. What if the temperature goes up by 1 degree, by 2 degrees, or there is a kind of change in nutrition, nitrogen, oxygen, then what happens to the coral community or the ecosystem? And the idea is to kind of take from coral reef and expand that to make it like digital shallow, like whole lake or whole ecosystem, not only coral reefs, but everything around that. And that kind of thing will change the way we are seeing the subsurface ocean, what is happening below the surface. And that is a kind of narrative I think will be kind of appealing to everybody. So, okay, this is what is our oceans, and we don't want to destroy that. That's the idea. And also we are doing a kind of virtual fish tank to understand the fish stock and the potential fishing grounds to kind of avoid overfishing, and as Tim was mentioning, underfishing. Both are not sustainable. So in that way, I think we need this kind of virtual systems which can give us idea about the fish stock and the potential fishing ground to avoid unnecessary exploitations, at the same time providing better return on the healthy ocean. And they are developing this model in a layered manner, integrating many layers, including eDNA into that. And this is a new kind of thing coming up, monitoring eDNA, so that we know the health of the oceans and how much we can get from that healthy ocean. The other thing people are doing now is kind of developing digital twin for blue carbon, like putting seagrass, macroalgal systems all around the coasts and see how much of carbon can be captured by that kind of community, and then try to make it more realistic in the real world so that we can expect some kind of carbon removal through that system. We are also developing regional hubs under this initiative called Ocean Prediction DCC. DCC stands for Decade Collaborative Center, one of the UN Ocean Decade activities. And under that, we are developing teams. We have now 8 or 9 teams. I'm heading the Western Pacific and marginal seas of South and East Asia, BMKG in that, and many other centers from Southeast Asia and also East Asia. And our idea is to do a kind of identify these 9 or 10 topics and make 9 or 10 teams, each team kind of working on either physics, biology, digital twinning, or the capacity development and other things. And then these teams from each region meet the other teams and kind of exchange ideas. Okay, in this area we have this kind of challenges, this is our gap, and try to learn from the other team how they fill those gaps, or if there is anything else they are bringing up, so that together we can understand the gaps and try to fill the gaps. We have like 4 pillars helping us to kind of address those 10 topics I showed you before. The first one is a technical framework, and then we have a team of experts, modelers, interface developers, and then try to make a technical architecture. At this moment, the technical architecture is digital twin of the oceans, which has everything, model, interface, monitoring in that, and include AI. The idea is to include AI into that. At the moment, we are discussing whether AI will be the central theme, or we keep AI as a side event and then a side thing, and then try to develop the system. At some point, maybe they will get integrated. The idea is like we need to understand physics. We need to understand the dynamics. So we cannot give up the conventional modeling systems. Those are helping us to understand physics and dynamics. At the same time, we know that AI is bringing some new kind of things which improves our predictions. So we cannot completely give up on AI either. So at the moment, we are thinking of making AI and conventional system together in a hybrid system. Eventually, when AI has more data and learns better, then maybe everything will move to AI. That's the idea at this moment. Then develop a community who can use this, both modeling community as well as the stakeholder community, and kind of discuss with them through forum, through different communication systems, and prepare the ETUF guide and technical architecture so that they can learn, the young generation who are coming in, they don't have to spend a lot of time like what we did, coding the models. We did that. So the new generation don't have to code because everything is available. They just need to see the guide and go through the stepwise what to do, and then the system is ready for them. That's the idea, to develop the capacity for the young generation. Then collaborate with different decade actions. You heard Goose, the Coast Predict, SynOps, all those decade actions must come together to exchange information and ideas to make the UN decade rich with information. Okay, that's my summary. So we have many challenges, but we know that we have information. Some are missing, but eventually we have all the information, and AI will help us to fill the data gap, to also improve our predictions, make the interface more user-friendly and more interactive, so that the oceans will be available to everybody. At the moment, it's a good narrative, but we need to improve on that and make it more appealing for everybody, so that we have a healthy ocean for healthy returns. Thank you very much.